Now coming to the postulates. Now here I will be using three, that is alphabets A, B and L. Now what is that? You see, A for the central atom, B for the surrounding atom, means around the central atom, the other atoms which are there, that is the surrounding atoms, and L for the lone pair of electrons. Alright, you can say B also for the bond pair also. We can also say this is bond pair. Alright, so A is the central atom, B is the surrounding atom or the bond pair, and L is the lone pair of electrons. You must be knowing what is lone pair. Lone pair means a pair of electrons which does not participate in bond formation after the central atom has attained the octet structure. Once the central atom attains the octet structure, you will find a pair of electrons, some pair of electrons, either it may be one pair, two pair, three pair, whatever it is. Some pair of electrons is left which does not participate in bond formation. That is called as a lone pair. I can immediately give you one example. See here, this is the structure of, this is the structure of water molecule. Now once we learn BSCPR, we need not draw as I was drawing linear molecule, we will be drawing in this way only. So you can see oxygen should have how many? 8 electrons, and hydrogen should have 2 electrons. Hydrogen duplet, see duplet, 1, 2, count it, see 1, 2 electrons. Here hydrogen is duplet, here this hydrogen also 1, 2 duplet. Alright, so as a result oxygen is having 1, 2, 3, 4 electrons. Now 5, 6, 7, 8, see here, I think you can see it very clearly. So in this way you can see here, that is this two pair of electron, this is one pair, this is another pair, these two pair of electron participates in bond formation. So this is known as bond pair. This is called as bond pair. Bond pair of electrons. Alright. Now this two pair of electrons, see, after attaining the octet structure, now oxygen is octet. How it is octet? 1, 2, 3, 4, 5, 6, 7, 8. So octet. So after oxygen has attained the octet structure, you can see very clearly two pair of electron does not participate in bond formation, which is known as what? Lone pair of electrons. That is what I am saying here. What is lone pair? Lone pair means a pair of electrons which does not participate in bond formation after the central atom. This is central atom. It's very important to say that. After the central atom has attained the octet structure. And always you will find the lone pair for the central atom only, not for the surrounding atoms. You will find the lone pairs for the central atom only, not for the surrounding atoms, because lone pair is a term which is used only for the central atom, not for the surrounding atoms. Suppose in the surrounding atom, let us say some lone pair is, some pair of electron is there which does not participate in bond formation, but that is not considered as a lone pair. For example, suppose if I say the molecule of sulfuric acid, if I say the molecule of sulfuric acid, we can say that. Clear? So here you can see is that S is the central atom. So here whatever the pair of electron is left which does not participate in bond formation, this is 2 are coordinate bonds. Okay. So it does not participate in bond formation. That is called as a lone pair. Because here you will find pair of electron which does not participate in bond formation. But that is not the lone pair. Here also you will find it out. That is not the lone pair. This is not the lone pair. Mind it, this is not the lone pair. This is a central atom. Here sulfur is a central atom. Here if any pair of electron is left which is not participating in bond formation, that is called as a lone pair. I hope you got it now. This is not the lone pair. In this example, in sulfuric acid, oxygen is not the central atom. It's the surrounding atom. Here the central atom is sulfur. So you will say, sir, here lone pair. No, absolutely wrong. For this molecule, this is not the lone pair. For this molecule, I am saying that. For this molecule, for sulfuric acid, here oxygen is not the lone pair. Understood? I hope you got it. Yes. Now, so hence, I will tell you the postulates now, and I will explain it also to you, the postulates one by one. The unpaired electrons in the valence shell of the central atom forms bond pairs with the unpaired electrons of the surrounding atoms, while the paired electrons remains as lone pairs. What I said it? The unpaired, the first point, the unpaired electrons in the valence shell of central atom. So central atom can have what you can say lone pair as well as what you can say bond pair. So what he is saying is there, the unpaired electrons in the, let me not write this. So this is your unpaired electron, this is your paired electron, as you can see very clearly. This is unpaired and this is your paired. So unpaired electrons, I am pointing it out, the unpaired electrons in the valence shell, this is your valence shell, let us say outermost shell of A, got it, forms bond pairs with the unpaired electrons of the surrounding atoms. Let us say surrounding atom is B, already I have told you. So with the unpaired electrons of the surrounding atoms, it forms bond pair. So B is having an unpaired electrons, A is having an unpaired electron. So they undergo to form what is that? Bond pairs. So again I repeat, the unpaired electrons of the, what you can say, central atom forms bond pairs with the unpaired electrons of the surrounding atoms. Alright? While the paired electron, let us say only one pair is there, only one pair, let us say, it forms lone pairs, while the paired electrons remain as lone pairs. Fine, the first point is clear. Now coming to the second point. Second point is says that lone pair and the bond pairs, they are similarly charged. Definitely, this is also made up of electron, this is also made up of electron. Lone pair is made up of 2 electrons, bond pair is also made up of 2 electrons. Now one bond pair is having 2 electrons. It can be from definitely different atom or same atom, whatever it is. Clear? So being similarly charged, they tend to repel one another. Definitely they will repel one another because they are similarly charged. Third point is that, third point. Got it? The second point understood, being similarly charged, they will tend to repel one another. Definitely. Because they are made up of electrons, whether it is a bond pair or lone pair. Now, third point is that, so as to have minimum repulsion and maximum stability, they will go far apart from one another. Suppose if these lone pairs and the bond pairs, they are closer to each other, or this bond pair and bond pair, they are closer to each other, being similarly charged, alright, as they are repelling one another, so as to have minimum repulsion, listen carefully, so as to have minimum repulsion and maximum stability, they will go far apart from one another. You will not take them far apart, they will itself arrange in that manner. Try to understand this point. We are not arranging them. They will itself arrange in such a manner so that the repulsion will be minimum. Got it? Clear? So the electron pairs, the next point is that, the fourth point is that the electron pairs around the central atoms set themselves in such a manner so that they have minimum repulsion and maximum stability. They set themselves, electron pair, they arrange themselves in such a manner. I told you before coming to the postulates. They arrange themselves in such a manner because they are directional. This is a covalent bond, it is directional. I am not talking about electrovalent bond here, it is directional bond. So, what you can say is that, so as to have minimum repulsion, alright, they will arrange themselves in such a manner, they will set themselves in such a manner so that they will have minimum repulsion and maximum stability. So, when they will set themselves in what? In a particular, that is nothing but angle. In a particular bond length, they will have a particular bond length, they will have a particular bond angle. Alright, hence they will have a definite geometry, a definite structure, we can say that. Alright, so that the force of repulsion among them will be minimum. Alright, this is the most important point. They will arrange themselves, they will itself arrange themselves in such a manner. Alright, now, next is the force of repulsion among the bond pairs and the lone pairs is not the same. Alright, it's not the same among the bond pairs and the lone pairs. Lone pair, the last point, this is the fourth point I have discussed with you. Now, fifth point. I said you, the force of repulsion among the bond pairs and lone pairs is not the same. Lone pair repulsion is greater, always greater than bond pair repulsion. Why? Because in lone pair, what you find is that, let us say that I am having 2 pair of electrons here. Let us say I am having 2 pair of electrons. Okay? Let me rub this. I am having 2 pair of electrons here. We are having 2 bond pairs here. Let us say 2 lone pairs here. So, lone pair means what I said? This pair of electrons that do not participate in bond formation. That means they have a complete electron cloud. Alright, a full electron cloud. So, when these 2 electron cloud will come closer to each other, apply the common sense, they will not repel one another. Definitely. They will repel one another. Alright. But in case of bond pairs, what happens is that they overlap in this particular way. This electron and this electron, they overlap in this particular manner. So, the electron cloud tends to shorten itself. But here, there is no question of overlapping because here they do not participate in bond formation. So, the electron cloud is of the normal size. Alright, it is, whatever it is, the same size we can say that. The normal size it is, the actual size. But here the size is smaller. Why? Because when they come closer to each other, the sharing of electron takes place, due to which the electron clouds tends to shorten themselves. Alright, because the, what I said, attraction is taking place. Followed? And here what is happened? Repulsion is going to take place. So due to repulsion, they will go far apart from one another. This it will shift here and this it will shift here. They will go far apart from one another. But here also the repulsion is going to take place, but here the electron cloud is shorter, it's smaller. So here the repulsion definitely will be small, and here as the electron cloud is bigger, the repulsion will be also bigger, will be larger. So hence for that particular purpose, lone pair repulsion is always greater than bond pair repulsion. Did you get it? This is a smaller electron cloud in case of bond pair, but in lone pair it's a larger electron cloud, because already I said you this does not participate in bond formation. It's the actual size, we can say that. Clear? So as a result, when they come closer, the two electron clouds, which is a bigger size, definitely the repulsion will be more, but here the repulsion is less. So hence always lone pair repulsion is greater than bond pair repulsion. Now, what is lone pair bond pair repulsion? We have talked about this and this. We have talked about this and this. What about this and this, or this and this? Lone pair and bond pair. Lone pair and bond pair. What about this? It lies in midway. It lies in between. It lies in between lone pair and bond pair. So hence ultimately what we can say, that is ultimately we can say that, let me make this one as bond pair and here let me write as lone pair. So what we can say, lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion, because here we are having two lone pairs, definitely it will be greater, two bond pairs which will be smaller. But here one lone pair and one bond pair, definitely due to the presence of one lone pair, what will happen is that the repulsion will be slightly more than this, than bond pair. So hence it lies in between for that particular purpose. So hence lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. I hope it's clear to you. So these are the postulates. The first point says that when the atoms they come closer, alright, that is this one, as you can see, this central atom, which is surrounded by the surrounding atoms. So first they form bond pairs with the unpaired electrons, and the paired electrons remain as lone pairs. You can see that. Now, being similarly charged, alright, this is not lone pair, alright, don't get confused. So being similarly charged, the lone pairs and the bond pairs, whatever it is, they tend to repel one another because they are same charges, electrons. Now, to have minimum, what you can say, repulsion and maximum stability, they will go far apart from one another, definitely. Next is, they will arrange themselves so as to have minimum repulsion, maximum stability. They will arrange themselves in such a manner so that the force of repulsion among them is minimum. They will set themselves, they will arrange themselves. Now, next, the force of repulsion is not the same. The lone pair is greater than, lone pair bond pair is greater than bond pair repulsion. So these are the 5 points or the postulates of the VSEPR theory. Next, I will tell you what are the applications of this particular theory and what we'll come to know about it, about the shape of the molecule. Okay, thank you.